Welcome to Metal Casting Lecture Series by Professor Joyjeet Ghose. This is the second lecture of a series of lectures. This lecture will be on fundamentals of sand casting processes. He will be discussing about sand casting terminologies and basic steps of sand casting. So, do not miss and watch the full video. For the next video in the lecture series, please click the suggested video link above. You may also click on the playlist at end of the video to access all the videos. Please subscribe this channel and yes, do not forget to like and share. Also click on the bell icon to receive instant information of new videos uploaded. Thank you.
Hello friends, welcome to this lecture 2 on casting. In this lecture we'll be having a brief discussion on the basic aspects of sand casting technology. So let us start with the terminology that is used in sand casting. I'll be discussing the basic terms that is used in sand casting. So let's start. So sand casting starts with construction of a pattern. What is pattern? Pattern is basically a primary tool that is used in casting process to create a shaped cavity that is called the mold. Now this pattern can be exact, almost, or approximate replica of the final casting. It can be made by various types of materials like wood, metal, plaster, rubber, plastic, etc., etc. So this pattern is used to make an impression in a molding materials to create a shaped cavity. So it starts with a pattern. Now this pattern creates a cavity which is called a shaped cavity, which is called a mold cavity. And this mold cavity is created in molding materials which is held in a flask which is called molding flask. Now this molding flask can be of 2 or more parts. Normally it is made of 2 parts. The upper half is called the cope and the lower half is called the drag. So the upper half is called the cope and lower half is called the drag. So if a pattern is also made of 2 pieces, the upper half will be called cope and the lower half will be called the drag. And the line that separates the cope and the drag, or the surface that separates, is called the parting surface. Okay, so core. Many a times we require to create internal features of a casting. Internal features of a casting can be made using sand, and a special type of sand rather, which is called core sand. The core sand is used to create a shape that is required for creating the internal features, and that shape is inserted in the mold cavity, and the metal will flow around that shape, and the internal features like holes can be created in the casting. Now, to insert this sand shape or the core in the mold cavity, we require to add a certain part to the pattern, to the core, which is known as core print, or to the mold, which is known as core print. Now this core print is the additional component that is added to the pattern, to the core, to the mold, to locate and to support the core. Now you want the core to be positioned accurately. You do not want it to be displaced. Therefore, we have to locate it correctly. So the core prints allow it to locate correctly, and under the pressure of the molten metal flowing it, the core should not be displaced. So it should be supported properly. Therefore, the core print provides the support that is necessary to hold the core under the pressure of the molten metal. So there is core and core print. You can see here, this part is the core print. Okay, this is the core print which is supporting from both sides. This is supporting from one side, and here this part it is supporting from the lower side, and this part is supporting from the upper side. So these are core prints. This core will the metal will solidify around the core and will take out the pattern, take out the casting, and will remove the sand shape to get the internal feature of the casting. So core print is the reason added to the pattern, core, or mold that is used to locate and support the core within the mold. Now, the molding material and the core then combine to form the mold cavity, the shaped hole in which the molten metal is poured and certified to produce the desired casting. Okay, now another interesting feature is riser. You'll see that all molds have risers. Mostly all molds will be having risers. You can see the risers here. This is a blind riser. This is an open riser. This is a this is a blind riser probably. Now this is open riser. This is also another open riser. So the two risers are there here. So what is this riser? Riser is an extra void created in the mold which is also filled with molten metal. So here you can see through this channel liquid metal enters the mold and ultimately rises through the riser. Rises in the riser. So this extra void also will accommodate molten metal. Now, during solidification of the liquid metal in the mold, it will sink. Now, if it sinks, it becomes smaller than the mold cavity that we don't want. So we have to compensate with more liquid metal. Now, the riser supplies this molten metal into the mold cavity during the shrinkage of the liquid metal. I repeat, during the solidification of the liquid metal in the mold, it will sink, and this is particularly called liquid shrinkage. There is another called solid shrinkage. Solid shrinkage is compensated by shrinkage allowances, but the liquid shrinkage will be compensated by the molten metal stored in the riser. I repeat, during the solidification of the liquid metal inside the mold, the size of the casting will shrink, and that we don't want. We want the size of the casting to be exactly the same as that of the mold. Therefore, you have to compensate the liquid metal into the mold, and this compensation is done by liquid metal in the riser. Now, riser is placed and designed in a such a way that the liquid metal solidifies in the riser at the end. Therefore, when the metal in the mold solidifies, there is enough liquid metal in the riser to compensate. I repeat, it is by design and by placement of the riser that the liquid metal in the riser will solidify at the end. Therefore, it is able to compensate with liquid metal while the metal in the mold is solidifying. Also, another aspect of riser is that when you fill it, see, if this open riser, the liquid metal will come out. If we are doing it manually, the operator or the foundry man will understand that the molten metal has completely filled the mold cavity. So that is a secondary function, not the primary function of riser. So it provides a reservoir of material that can flow into the mold cavity to compensate for any shrinkage that occurs during solidification. The gating system is a network of channels that is used to deliver the molten metal to the mold cavity. Now we have made the mold. Now we have to deliver the molten metal from the top to the mold cavity. Now the network of channels that is used to deliver the molten metal from the top to the mold cavity is called the gating system. Gating system consists of the pouring basin, the sprue, the runner, and the gate. Four components are there. I repeat, pouring basin, sprue, runner, and gate. Now, pouring basin is the cup on which the molten metal is poured. Molten metal is not poured directly in the sprue. It will be poured in the cup, and slowly from the cup it flows through the sprue. Sprue is tapered down. Now, why we are pouring slowly? Now, pouring is very important in casting. We don't want to pour very rapidly. It will lead to turbulent flow, which we don't want. In case of turbulent flow, it will erosion, sand erosion may take place. It will take in more air and it will cause defect in the casting. That we don't want. We want to flow it slowly but steadily, not too slowly also, because it will solidify in between the gating system. In this gating system, we want it to solidify in the mold. So it should not be too slow, but it should not be too fast also. So therefore, we pour it indirectly in the pouring cup, and from the cup it overflows and flows through the sprue. The sprue is intentionally made tapered to reduce the air expansion. That you will understand later, and it falls into the choke, and from the choke, the sprue is the vertical channel. Sprue is the vertical channel, and it reaches the choke, and from the choke slowly it moves through the runner, and from the runner it enters through several or one control entrances which we call gates, or sometimes referred to as in gates. So again I repeat, gating system consists of the pouring cup or pouring basin, the vertical channel called sprue, the horizontal channel called the runner. There is a choke where from the sprue it reaches the choke, and from the choke to the runner, and from the runner ultimately to the mold via the gates. The cross section of the gate can be controlled by design, and you can control the flow of molten metal in the mold cavity. Now, some additional vents are provided in the casting. These are called vents. See, several vents are created here. One is shown here. So these vents are created by vent valves. These are basically passages for gases to escape. Now, molten metal contain dissolved gases, and also hot molten metal, which comes in contact with the moisture, creates steam. The hot gases of the molten metal and the steam that is created should have passages to escape. Otherwise, it will be absorbed in the casting, and it will create a defect called different types of defects are created by these absorbed gases. One of such defect is called the blowhole. So we don't want such defect to happen. Therefore, we should allow the gases to escape. So one of the way of allowing the gases to escape is creating vents. Parting line I have discussed already. Chaplets. Now, sometimes the shape of the core is such that it has to be supported from the other side, not by core prints, by chaplets. Now here, see, it is dangling here, and this is supported from one side like a cantilever. Now under the metallographic pressure or liquid metal pressure, it may change its position. That we don't want. Therefore, you have to support it properly. Here we are supporting it some metallic objects which we call chaplets. These metallic objects should be made of metal which you are casting. Suppose you are casting aluminum alloy, so this should be made of aluminum alloy, because it will solidify along with the liquid metal, and you cannot remove it after solidification. So it will also solidify along with the and be a part of the product. So these are called chaplets. Sometimes you want directional solidification. That means you want certain portion of the casting to cool fast. Now, the cooling in a casting is very important, because if it does not cool uniformly, the shape may get distorted. These are called thermal defects. Now, certain areas, particularly thick areas, needs to be controlled. The cooling needs to be controlled, or the cooling needs to be increased. Now, if you place certain metallic objects in the mold, let's say if I place a metallic object here, metallic object we all know has a better thermal conductivity than sand, then the heat transfer rate will increase in this area, and probably this portion will cool faster. So certain areas which requires faster cooling, particularly thick sections or corners, such regions can be controlled. Solidification can be controlled by using certain metallic objects inside the mold, not in the cavity. Mind you, not in the cavity, and that part, that metallic object does not form part of the casting. Rather, it remains in the mold, which you can take it out later on. These are called chills. And lastly, the term casting is used to describe the process as well as the product. The product is also called casting. The process is also called casting. The product is also called casting. This particular process that I have discussed, or the terminology that I have discussed, is of sand casting. So you can see here, so this is the core, this is the core print, this is the sprue, this is the riser. Sorry, this is the pouring cup, this is the sprue, this is the riser. So here, for different aspects, you can see here, this is the riser, blind riser is there, this is the casting, this is the mold cavity, this is the core, this is the pouring cup, this is the runner. Here, this is the gas vent, This is the blind riser, pouring cup, runner. This is the core. Similarly, runner. This is the runner. Sorry, this is the sprue. It is not runner. This is the sprue. This is pouring cup. This is the runner. This is the ingate. This is the riser. This is the core. I hope this is clear to you, the different terms which you'll be using in subsequent lectures, and you will be able to understand what I'm talking. Okay, some of the equipments that are used: riddle, rammers, shovels, strike-off bars, vent wires, sprue pin, lifters, trowel. Each has its own applications. This probably you will be doing it. If you do labs, then you will be practicals, then you will be using these equipments. This is a flat end cleaner. This is a trowel. This is straight edge. This is knife end cleaner. Vent wires with which you can bend holes. Smoothers. Draw spike to remove the pattern. Shovels. Rammers to ram the sand in the mold. Okay, so these are the various equipments that are used. Now, the basic process, let me again discuss. First is that we make a mold. For making a mold, we require a pattern, a core. We assemble the pattern to create a mold. After the mold is created, we fit the core. Core is made separately, and the molding sand is made separately. So all these are made, assembled into the mold cavity. Then liquid metal is melted and poured in the cavity, and then slowly it solidifies, and we take it out. The sprue, the runner, the riser, all remains attached to the casting, and we cut it off and then we finish it off. That is the basic sand casting. But one factor is common to all, is that we require a mold. Now this mold can be permanent or it can be single use. In sand casting it is of single use, and if it is a single use pattern mold, we have to use a pattern. The pattern can be single use, it can be multiple use to create the mold. And then we pour the molten metal in the mold and allow it to solidify. That is common to all casting techniques, apart not only sand casting. So in sand casting, we have to make patterns, we have to make core, and the sand is made. So entire thing is assembled with gating system, and then we melt the metal in a furnace, pour it in the mold, solidifies, take out the casting, which is called check out and removal of risers and gates, and heat treatment if required, else cleaning, finishing, and then inspection for any defects and dimensions, then it is shipped. So the layout of a foundry looks like this. So this is the melting. You can melt it by cupola, you can melt it by electric arc furnace or induction furnace, and this is the sand where you prepare the molding sand. This is a machine molding, and this is core making. So you make the mold using the pattern, and then you fit it, and these are going in line. Molten metal is poured, you check it out, and then cleaned, cutting off, cleaned, and then shipped. So this is the basic layout of a foundry. Now, one important point I want to make here is that we can cast complex shape. Now, the limitation of the complexity is whether it is possible for us to create that complex mold. Now, how to create that complex mold is using pattern. Now, the limitation actually lies in removal of the pattern. If the shape is such that we can remove the pattern easily, then it can be created. We can do sand casting. So the actual limitation is the removal of the pattern. So therefore, patterns are of various types. In the next lecture, I'll be discussing will be devoted entirely to pattern. Pattern has to be removed from the mold to create the mold cavity. Remember that. So removal is important. So next lecture we'll be discussing about pattern and pattern making and all aspects of pattern allowances, etc., etc. So I'll be ending in this lecture here. Thank you for patiently hearing my lecture, and if you have any doubts, please feel free to comment it in the comment box, or you can mail to me directly. Thank you once again.